Thank you for joining us today. This is our fourth session of the Oklahoma Excavation Safety Expo. This session is going to be over excavation safety as well as trenching safety. And Buddy Myers with Excel Group is going to be doing that training. If you have not used our GoToWebinar interface before, there is an orange arrow. That is the key to the interface. If it disappears on you or if you need to get it out of the way, use that orange arrow. It's going to minimize or maximize that interface. At any time, if you have any questions, you can submit those questions to us by using the question feature. All attendees are muted just for the amount of people that we have attending. It's just so much easier to do it this way. So use that question feature, send those questions to us so that we can get those answered towards the end. Also, towards the end of our session, we are going to be doing a drawing for a $100 gift card to Amazon. So be sure to stick through that drawing as well. So, Buddy, are you ready to go?
I'm ready, sir.
All right. Do you have your screen shared for me?
I hope so.
Let me see if we got you up and running yet. All right. I don't show your monitor yet. There we go. There you go. Okay. All right. With that, let me turn it over to Buddy, and he is going to share his presentation now.
Thank you very much, MG. Certainly appreciate the opportunity to be a presenter for the 811 Expo again this year. Good afternoon, everyone. Thank you for joining us. My name is Buddy Myers. I work for Excel Group. We're a cross-bridge group company. We're an industrial service company with a unique blend of services focused on the compliance needs of a lot of general industries type out there, construction, oil and gas operations. You can see the list there. I'm the Oklahoma Regional Manager of Safety, OQ, and DOT. So, safe excavation and trenching. That's what we're going to talk about a little bit today. Been doing this for a long time. I became an excavation and trenching instructor back in the old days in 1993 when the big push came for excavation and trench safety was implemented to reduce accidents and injuries, fatalities as a result of catastrophic incidents in digging and excavation. The purpose of the excavation and trenching program or safety program out there, or law or regulation or company compliant request, is to ensure that persons that are working in or around excavation, trenches, ground disturbances, which has become a catchphrase in the last 5 years or so, do so in such a manner that the people, the environment, and the equipment is protected properly. And it's additionally to comply with applicable laws and client requirements out there when we're performing work in exchange for financial reward, which is why we all get up and go to work every day. Anytime that you're talking about safety, the order of protection is always going to be, number one is people, employees and the public, the environment, and the equipment that we're working with out there. There's three types of processes out there, reference to surface removal disturbance that need to be addressed in safe trenching and excavation. And one is an excavation. An excavation is considered a man-made cut, cavity, trench, or depression in the Earth's surface formed by earth removal. And that definition is per the OSHA standard. A trench is simply a narrow excavation in relation to its length, made below the surface of the ground, and that's per OSHA as well. Ground disturbance is any action that disturbs the surface of the earth regardless of the depth or the length, and that's really a client definition out there. We have worked on some job sites, done the safety representation where dragging a simple garden rake across the top of a gravel pad is considered a ground disturbance. Worker safety on excavation and trenching and ground disturbance job sites. Depending on the sources that you look at, there's up to 100 fatalities with approximately, and that should be 1,000 more injured per year. That's a typo for me. Most of those companies are with fewer than 50 employees. And I think probably the reason for the company size having more accidents or more incidents with employee sizes of smaller companies is that the smaller the company, possibly the less responsibility, less people to spread the responsibility around to work a little bit safer. We're not as much under a microscope where you get looked at quite as closely. So maybe tempted to take some shortcuts. Maybe the training dollars are not there to reinforce the necessary requirements or steps to take when you are involved in a trenching and or excavation exercise. Okay, let's do that right there. There's numerous hazards that can create death or injury in and around excavation, trenching, and ground disturbance sites. The top 5 of those would include trench collapses, falls, falling loads, hazardous atmospheres, mobile equipment, or underground strikes of utilities, gas, electric, those type of things. Trench collapse simply is basically when the sides of the trench wall will slough off and trap someone inside of a trench, cover them with dirt, which is about 3,000 pounds per cubic yard of dirt when it falls on top of you. So it's a pretty heavy load that would happen there. Numerous causes of trench collapses could be trench has been open for a few days, the sidewalls have dried out, they started to crack. Surcharge loads or weight on the side of the trench could also be an issue with that. Vibration could create problems with that. There's other machinery, pile drivers operating near the trench. Maybe even something as simple if you're working near a public roadway, traffic running back and forth. I know some of you probably stood on bridges before when a large truck or a large piece of equipment has crossed that bridge and felt that bridge actually vibrate and shake. So the same thing happens to the ground, those vibrations in that surcharge load near a trench when there's traffic. Falls and or falling loads. Fall would simply mean someone that is attempting to work near or across a trench improperly. So maybe they could fall into the ditch, into the trench, and create an injury or fatality situation that way. Falling loads, some kind of equipment failure. Maybe we're lifting pipe, trying to lower it into the ditch. Maybe we're trying to continue to dig and move spoil piles away from the ditch. Maybe a equipment failure. Hazardous atmospheres. Obviously, there's several things that can cause hazardous atmospheres, one of which is if your trench is in the proximity of, let's say, an old landfill, a swampy ground where H2S gas would naturally be occurring, it could migrate into the trench. Maybe we're working in a city environment or town environment where we're close to a sewer line that might have some kind of crack or problem there. The H2S gas would migrate out of that facility into the trench. By nature, H2S gas is about 20% heavier than air, so it would sink to the bottom of that trench, and then you could end up having a poison gas atmosphere in the trench at some level, as gases will stratify when they get into an environment where there's not any crosswinds or a lot of wind to make things continue to be stirred up. Mobile equipment, obviously track hoes, backhoes, bulldozers. Anytime they're moving around an equipment site or a job site, we could have the possibility of some of those striking a worker that may be near the trench on the excavation. And it's possible if you're working near a public roadway, it could be that someone traveling that public roadway could strike a employee that's working there. And underground strikes of utilities, gas, electric, those type of things, we all kind of know what those mean. And those most usually are catastrophic at a minimum to whatever equipment is involved in that strike. So how do we protect our workers? The first thing we have to talk about is with protecting our worker is in your company, you've got to have a safety culture. You've got to be bought into the program. You've got to make safety a lifestyle that you continue with even when you leave the workplace. So excavation and trenching. Let's identify and mark the job site. The standard out there in OK 811 is very proactive in promoting the safe excavation and trenching programs, and they have a variety of things on their website that you can look at to utilize for training. White flags or white paint are used to mark the excavation site so that locators can identify the area that needs underground facilities located and marked prior to any ground disturbance activity. So one of the things that's included in the 811 call process is sending an employee out that has the authority and the ability to mark that excavation site. Obviously, we have pipelines, utilities crossing sections of land, but we wouldn't want to have to mark the whole section, the entire section, when we can simply mark the areas that are inside the proposed excavation site or ground disturbance or trenching site. So we're going to call that 811 number, which is the national call before you dig phone number, to request buried utilities approximate locations be marked by their owners. Make that phone call. The call811.com is a website with every state's information in an easily accessible format. On that website, you can go and you can look at requirements of, for example, what's the state regulation on hand digging or no motorized digging within how far from the center line of the utility that's being marked there, so that you can avoid striking that. Oklahoma is 811 or the 800 number, or you can visit okie811.org. Each and every excavation site needs a competent person, if someone is going to enter the excavation or trench. There can be more than one competent person on the job site. Each competent person has the responsibility to make sure that it's a safe work site, but there has to be one person in charge, the primary competent person, who is capable of identifying existing and predictable hazards, and working conditions that could be hazardous or unsanitary, dangerous to workers, soil types, protective systems required, and this person must be authorized to take prompt corrective measures to eliminate whatever hazardous conditions are occurring or about to occur, or terminate the worker entry, or make everybody exit the trench or the excavation until that hazard has been eliminated. Could be hazardous atmosphere, changes in the atmosphere. It could be that we've had a motor vehicle accident on the right of way where the attention has been focused away and we've got people milling around that shouldn't be there. It could be that we've got an inspector walking up close to the edge of the trench and kicking dirt off in there. There's anything that would present danger to any employee that would be inside of the excavation and or the trench. Prevention of cave-in events is one of the most important safety considerations that must be addressed by the competent person. Prevention of cave-ins. How do we prevent cave-ins? He needs to be skilled and trained in how to do that. What protective measures can we take to keep a trench from caving in on a worker before they go into that trench? Prior to implementing cave-in prevention measures, soil must be classified as to what type of or combination of types that exist in the excavation and trench. And we all know, most of us know anyway, that there's 3 soil classifications out there. We're going to go with type A, type B, and type C, with type C being the most common, basically because the definition in the state of Oklahoma, the definition of type C soil is, and we'll see what that is here in a few minutes, but the addendum to that is any previously excavated soil. And how much soil is there in the state of Oklahoma that's never been dug up? Don't think there's very much out there. OSHA's got a very good video. It's about 11 minutes long It talks about soil classification. You have to have at least two methods of classifying soil before you can actually put a type to it. And this video is pretty simple, pretty easy to follow, pretty easy to understand, and it's accessible on the OSHA website. And technologically challenged I am, we are going to see if we can make it go.
If you're having any problems with it, buddy, let me know. Looks like you got it.
Yeah, I think we're maybe we're going to get there, I hope.
In the U.S., more than 800 construction workers die every year while on the job. One of the most dangerous types of construction work is trenching, which kills 40 construction workers every year.
Are we going, MG?
It was going. It cut off short. That's no good. You want to try that one more time and see if the full video is there or if it uploaded wrong?
In the U.S., more than 800 construction workers die every year while on the job. One of the most dangerous types of construction work is trenching, which kills 40 construction workers every year. Workers can suffer death or serious injury within minutes of being caught in a trench cave-in. But these deaths can be prevented. The video you're about to see shows one of the steps, classifying soil, that employers must follow so that trenching work can be done safely. This video is not intended to be a complete educational tool. Instead, it is meant as an introduction for In the U.S., more than 800 construction workers die every year while on the job. One of the most dangerous types of construction work is trenching, which kills 40 construction workers every year. Workers can suffer death or serious injury within minutes of being caught in a trench cave-in. But these deaths can be prevented. The video you're about to see shows one of the steps, classifying soil, that employers must follow so that trenching work can be done safely. This video is not intended to be a complete educational tool. Instead, it is meant as an introduction for people who want to know more. Employers have a responsibility to provide a safe workplace and required protective equipment. You'll learn how having the right information about a construction site can help save lives. Each employee who enters a trench must be protected from cave-ins by a protective system if the excavation is 5 feet or greater in depth, unless it is dug into stable rock. A support system is not required if the trench is less than 5 feet in depth. An examination of the ground by a competent person provides no indication of a potential cave-in. 1 cubic yard of soil can weigh as much as a car, 3,000 pounds, and comes in many varieties. Some types of soil are stable and some are not. When digging a trench, it's important to know the type of soil you're working with so you know how to properly slope, bench, or shore the trench. This can help prevent a cave-in. OSHA requires that employers have a competent person to determine the soil type. A competent person is someone who can identify conditions that are hazardous to employees and who also has the authorization to correct these hazards. All trenches that are 5 feet or deeper must follow OSHA's rules. The appendices of the OSHA excavation standard show the various types of support systems that may be used, up to a maximum depth of 20 feet. Any excavation deeper than 20 feet must use a protective system approved by a professional engineer. For all excavations, a competent person must conduct a full investigation every day, or when any trench conditions change, to identify and remove any potential hazards. In this video, you'll see how a visual inspection of a construction site's soil is performed. You will also see how to test the soil using 3 of the most common methods: the plasticity test, the thumb penetration test, and the pocket penetrometer test. For best results, OSHA recommends that the competent person use more than one of these methods to test the soil. Knowing the type of soil makes it possible to determine the right protective system to keep workers safe when they're working in an excavation. Soil can either be cohesive or granular. Cohesive soil contains fine particles and enough clay so that the soil will stick to itself. The more cohesive the soil, the more clay it has, and the less likely a cave-in will happen. Granular soils are made of coarse particles, such as sand or gravel. This type of soil will not stick to itself. The less cohesive the soil, the greater the measures needed to prevent a cave-in. OSHA uses a measurement called unconfined compressive strength to classify each type of soil. This is the amount of pressure that will cause the soil to collapse. This value is usually reported in units of tons per square foot. Soils can be classified as Type A, Type B, or Type C. Type A soil is the most stable soil in which to excavate. Type C is the least stable soil. It's important to remember that a trench can be cut through more than one type of soil. Let's look at each type of soil. Type A soil is cohesive and has a high unconfined compressive strength, 1.5 tons per square foot or greater. Examples of Type A soil include clay, silty clay, sandy clay, and clay loam. Soil cannot be classified as Type A if it is fissured, if it has been previously disturbed, if it has water seeping through it, or if it is subject to vibration from sources such as heavy traffic or pile drivers. Type B soil is cohesive and has often been cracked or disturbed, with pieces that don't stick together as well as Type A soil. Type B soil has medium unconfined compressive strength, between 0.5 and 1.5 tons per square foot. Examples of Type B soil include angular gravel, silt, silt loam, and soils that are fissured or near sources of vibration, but could otherwise be Type A. Type C soil is the least stable type of soil. Type C includes granular soils in which particles don't stick together, and cohesive soils with a low unconfined compressive strength, 0.5 tons per square foot or less. Examples of Type C soil include gravel and sand. Because it is not stable, soil with water seeping through it is also automatically classified as Type C soil, regardless of its other characteristics. Before testing the soil, it's useful to perform a visual test of the construction site. This will help determine if there are factors on site that will lower the strength of the soil. Here are some observations to make when performing a preliminary visual test of the soil around an excavation site. First, as the soil is being excavated, does it come out in clumps or is it granular? Clumps mean that the soil is cohesive. Are there sources of vibration near the excavation? Are there signs of previously disturbed soil, such as utility lines? Are there signs of water seeping through the soil? Is the soil fissured? Signs of fissuring include crack-like openings or chunks of soil that crumble off the side of a vertical excavation wall. If any of these conditions are met, the soil cannot be classified as Type A. When performing a soil test, it's important to choose a good soil sample. Soil samples should be typical of the surrounding soil in the excavation, and additional samples should be taken as the excavation gets deeper. While the excavation wall is one place to take samples, OSHA recommends taking a large clump from the excavated pile, as long as the soil in the pile is fresh and hasn't been compacted. Test results can change as the soil dries out, so for the best results, samples should be taken and tested as soon as practical. Now let's look at the three main types of soil tests. The plasticity test, which is sometimes called the pencil test, is used to determine if the soil is cohesive. This test is performed by rolling a moist soil sample into a thread that's 1/8 of an inch thick and 2 inches long, resembling a short, slim pencil. If the sample can be held at one end without breaking, it is cohesive. Here's an example of what the results will look like if the soil is cohesive. Notice how the sample stays in one piece. Now look at what happens when the soil is not cohesive. The soil doesn't have the strength to hold itself together. Any soil that is not cohesive is automatically classified as Type C, although some Type C soils are cohesive. The thumb penetration test is used to quickly estimate the compressive strength of a cohesive soil sample. To perform the thumb penetration test, simply press the end of your thumb into a fresh clump of soil. If the soil sample is type A, your thumb will only make an indentation in the soil with great effort, as you can see demonstrated here. If the soil sample is type B, your thumb will sink into the soil up to the end of your thumbnail, just like this. If the soil sample is type C, your thumb will sink all the way into the soil clump, as you can see here. Your results for this test will probably be somewhere in between these results. For a more numeric measurement, the pocket penetrometer test can be used. A soil's compressive strength can be given a numeric value by using the pocket penetrometer test. There can be some variability in these results, so it's a good idea to run this test on a few soil samples from the same part of the excavation, just to make sure your results are consistent. A pocket penetrometer works much like a tire pressure gauge. A thin metal piston is pushed into a soil sample, and the penetrometer records the compressive strength of the soil. Be sure that the scale indicator is inserted into the penetrometer body until only the 0 mark is showing. To conduct the test, push the piston into the soil until it reaches the engraved line. Then simply take the reading from the scale indicator. It's important to recognize that a penetrometer may give false results if the soil contains rocks or pebbles, which won't compress. As you can see, type A soil will measure at least 1.5 tons per square foot. Be aware, however, that you can't classify a soil as type A if the excavation site didn't meet all the conditions of the visual test. If it is granular, near a source of vibration, or there are signs of previously disturbed soil, water seepage, or fissured soil. For type B soil, the reading will be between 0.5 and 1.5 tons per square foot. Type C soils are equal to or less than 0.5 tons per square foot. Let's review the main points from the video. OSHA classifies soils into 3 main groups: Type A, Type B, and Type C. Type A is the most stable, and Type C is the least stable soil. To determine the soil type on a construction site, there are several tests that a competent person can use. After performing a visual test, you can use the plasticity test to determine if the soil is cohesive or granular. For cohesive soil, the thumb penetration and pocket penetrometer tests help determine the unconfined compressive strength. Determining the type of soil on a site will help a competent person decide which methods of sloping, benching, or shoring are needed to prevent cave-ins and keep workers safe. For more information, visit the OSHA website at www.osha.gov, where you can read the OSHA Excavation Standard, or use OSHA's Construction e-tool for trenching and excavation. You can also contact OSHA at 1-800-321-OSHA. That's 1-800-321-6742.
Perfect. There you go, buddy.
Okay,
You got it figured out.
I think we made it back. At 66 years of age, I've only been texting for about 5 years, and they've drugged me into technology, kicking and screaming. But I suppose it's a good thing. So. Yeah, let's back her up one there. Okay, cave-in protection. Once we classify that soil somewhere between A, B, C, and solid rock, and you're probably not going to find much solid rock anywhere in the United States, but I've seen it one time in about 30 years, which was down near Big Spring, Texas one time. But it's going to be a safe bet. Anytime you're on an excavation and trenching site out there, if your competent person is unsure, just to classify your soil as type C. Take your type C precautions, and then if the regulatory agency folks show up, you'll be protected. So, anytime a cave-in protection is required, sloping in or benching is the most common method of protection. The only limitations on it's the most effective, it's the most cost effective, it requires less equipment than anything else that's not already on site to implement. The one limiting factor of that is space. For example, if you're working in a larger city, if you're working on let's say a storm sewer on the right of way of a highway or a street, sloping and benching is going to be difficult because you can't cut back far enough. There's not enough room to cut back to get the slope angle that you're needed to be legal. Because obviously, if you're working on the right of way of a city street or a highway, most of that's been previously disturbed. You're also going to have the hazards of continuous moving traffic, so you're probably going to need to go with Class C on that or Type C on that, and it's just going to be difficult because of the space there. Start off looking at this. This is called a simple slope. In Type B soil, a simple slope will be from the intersecting line of the bottom of the trench and the vertical rise. From that point, however deep you are, you need to go 1 foot back for every 1 foot that you're deep. So if up to a 20-foot maximum, we'll talk about that just in a little bit. So if we're looking at that slide there, if that trench is 10 feet deep, then you have to go from that corner at the bottom of that trench to where that 20-foot max line is going up. You have to slope back 10 feet. So the bottom of your trench there is, let's say, 5 feet deep. How wide is the top of your trench going to have to be? It's going to have to be 20 feet, 10 feet on each side, plus the width of your trench at the bottom. So as you can see, Type B on a 1-to-1 slope is going to be pretty difficult to achieve. This is kind of a combination thing. This is a slope over bench. You can obviously see why we're calling that a bench at the bottom. They chose to bench the bottom 4 feet of it and then slope it back for the rest of the trench there. The first 4 feet are a given in generally any trench or excavation out there, or whatever you're going to do at the bottom of that's going to satisfy regulatory agency inspectors for the most part. This is a benching in Class or Type B soil, and that's just like a stadium seats or bleacher seats. It's just benching. And again, you have to continue with the 1-to-1 ratio. For every foot deep, you've got to have a foot back away from the edge of the trench. Simple slope in Type C, it actually grows much wider. We're going to go with the same 10-foot deep trench here, but for every 1 foot that you go deep, you're going to have to be 1.5 feet back from that intersecting line to the bottom of that trench. So if we have the same 10-foot trench here that's 5 feet wide at the bottom, obviously we're going to start with 10 feet, and then we're going to have to go 15 feet on each side. So there's a 35-foot wide excavation into the earth. You have to spoil pile must be a minimum of 2 feet from the edge of the trench. So you've dug your trench, you've laid your spoil pile back. You're already at 37 feet wide plus your spoil pile, which is going to be about 6 to 8 feet in width at the base. So you're talking about a minimum of about 40 feet to actually get to simple slope in Type C soil. Type C soil is the most common soil out there. The simple slope is the most common method used to protect employees or workers. And again, we want to point out that this sloping, benching, and other things we're going to look at only come into play if someone is going to enter the bottom of that trench to perform work. That's the only time you have to do that. What we're looking at here now is a trench box. Obviously, there wasn't enough room to slope back. It wouldn't matter if this was A, B, or C type soil. This trench box makes it legal for someone to go into the trench and work, or into the excavation and work, as long as they're not working underneath equipment that's overhead, as long as That trench box extends a minimum of 18 inches above the edge of that trench, and as long as there is a means of ingress and or egress for employees that may be in there, placed in such a manner that they don't have to move any more than 25 feet laterally to get to the exit point. That ladder obviously needs to extend about 2 feet above the top of that trench box. It does need to be tied off or secured whenever it's placed in there. And if that trench box was 50 feet long, or if that trench box was 30 feet long, it would require 2 ladders in there. The worker has got to be able to reach an access point, an exit point within 25 feet of lateral movement. Even if you're doing simple slope and there's going to be an employee, there has to be a way for that employee to exit that excavation where they don't have to move more than 25 feet. You can actually build an earthen walkway. You can actually bench that thing so that they can walk up it, but that ingress and egress point, if you're just digging it into the earth, has to be configured in such a way that the employee can walk in a semi-erect position as they go in and out of that excavation, which basically means you can't crawl up it on your hands and knees and try to exit that way. So that's a trench box used pretty widely in municipal and towns and cities and along roadways and things like that. Very good way to protect employees. Relatively expensive if you don't own one to rent them, but it will protect your workers that are in the excavation. This is a stacked trench box. Actually, what they did was they took 2 of those trench boxes, stuck them on top of each other, put the pins in place. Again, on this, it's got to extend above the edge of the excavation, and it has to have a means of exit for the employees to get out where they don't move more than 25 feet in any direction. The hardest thing to do is train your employees to not work outside of that trench box for any reason. Several job sites in the last 6 months I've been on, they put the ladders in the trench at the end of the trench box, next to the trench box instead of inside. That exit means it's got to be inside that box so that the exit is also protected from a cave-in. This is shoring and shielding. It is probably the least utilized method of holding the walls of a trench back. Basically, it's the cost. OSHA has a form in the OSHA standard that talks about how you can build shoring and shielding out of wood. It takes full dimension wood. It's got to be a certain kind of wood. It's just very difficult to do that. So the guys that are engineers have come up with this shoring and shielding. It's hydraulic, and what they do is they place the sides in there, then they put the hydraulic rams in there and obviously pump them apart and lock them in position to hold that. Again, with this type of protection, you have to not move more than 25 feet laterally to have a way to exit. These are constructed from the bottom up, and they're taken out from the bottom up whenever you decide you're going to take them out. Some places you can rent this equipment, and if it's going to be long term, it's going to be relatively expensive. It's also time prohibitive as far as putting it into the trench. So unless you're going to have a trench that has to be open for an extended period of time, a better method is actually the trench box. So we've discussed definitions of excavation, trenches, and ground disturbances, along with protective measures utilized for protecting workers that may be entering a workspace, meeting the definitions contained in the excavation and trenching standards and guidelines. So what we need to do during that JSA, JHA process is we need to figure out, have we been located? Did we call in the right legal description so that underground utility owners can come out and mark their lines? Do we know what each flag means? What color of each flag means? Do we know what kind of utilities may be underground? It's all important information to have. You identify that during the JSA, JHA process. If you can also classify your soil during that process. It allows you to plan your employee protection activities. Do we need to get a trench box started this way? Are we going to need 2 trench boxes? Do we have enough area to slope and shore? Are we going to utilize shielding? All that changes based on soil classification types. Other issues the competent person may need to address include, but are not limited to, water accumulation. If you have water accumulating in your trench or your excavation, that makes it mud. It makes it softer at the bottom side, makes it more likely to slough off or kick out so that the trench could collapse on an employee if they happen to be in there. Stability of adjacent structures. The small town where I live, they were doing sewer work. The building next to the alleyway wasn't really stable. It ended up in the bottom of their trench. So utility poles, sidewalks, buildings, roadways, those have to be addressed. How are we going to keep that from affecting our trench or our excavation while we're there? Hazardous atmospheres. Do we require our guys to wear monitors when they go in there? Are we going to test the atmosphere before we send anyone in there? Do we have adjacent vibration? Is there road work? Is there a bridge? Are they doing pile driving a half a block away? So the competent person must inspect that at a minimum once a day prior to work beginning. And then after workday breaks, if everybody leaves the location, goes to lunch, they come back, how do we know something hasn't changed? What if we have a significant weather event? What if a rain shower comes through, a hailstorm, we drop a little snow in there? Anytime there's a change in conditions within the excavation or trench may have occurred. The standard doesn't say if it does occur, it says it may have occurred. Then there needs to be a new inspection by that competent person. The inspection must be documented or it did not happen, and that's part of the standards out there. There's thousands of forms out there you can utilize to document trench or excavation inspection. OSHA has them on their website. Your company probably has one. My company has a generic one that we can provide if we do safety work on your behalf. There's a lot of them out there, and it's just pretty important that that be documented, because if it's not written down, it did not happen. And I think that this is just my part of it. My recommendation is we recommend that inspection by the competent person prior to the JSA, JHA process. Come in the morning, you inspect your excavation or your trench, and then you can report conditions back to the guys that are going to be working there via the JSA, JHA process, so they're getting real-time information. So, reviewing of what we discussed today, any type of ground disturbance has the potential to be hazardous. If you've got a garden rake, you're going to drag it across the ground, you're going to go somewhere between a half inch to 4 inches in the ground. Do you know what's under there? We have no idea how deep that electrical line is. So we're always going to identify work areas, make your 811 call to verify the existence or non-existence of underground facilities and their approximate locations. Also, we need to remember that not all underground facilities are part of the 811 map. There's some folks out there that put stuff in the ground that don't ever report it to the 811 people. So therefore, it's a possibility that you could be striking something there. You can drive the section line. You can look for road crossing signs. You can look at fence lines. You can look for places where you think pipelines or facilities may go underground. Just vigilance is very, very important in the excavation and trenching process. You need to designate the primary competent person and verify the inspections are performed and documented. You know, if I'm a competent person, but I'm not the primary, and you do the inspection, do I need to review your inspection? Probably not. If we work together, I probably should trust you. But we also need to watch out for each other. Regulatory agency inspector shows up. Who's the primary competent person is? That's the guy that's going to be talking, or the girl that's going to be talking to those regulators about inspections, whether they're performed. Utilize the protective measures identified in the JSA, JHA process. Get your trench box out there. Get your slope and your shoring, benching correct. Always have in and out methods available so that employee doesn't have to move more than 25 feet in any one direction. If you have employees that need to be crossing from one side of a trench to another, they need walkways so they can cross over. The walkway needs to be secured. It needs to have handrails on it so that we don't have a fall incident occur whenever they're crossing over. Slope shore shield is needed, including stop logs near excavation trenches if vehicular traffic will be nearby. If you're having to haul away the spoil pile instead of just stacking it up next to it, you got dump trucks coming in there. Where should we put the stop logs in case they get too close where they have to back in and bump it? My recommendation is a minimum of 2 feet from the edge of that excavation, because that's where your spoil pile is going to start. And if they get closer than 2 feet, the surcharge load on that trench wall could cause a cave-in or a catastrophic incident. Remind equipment operators spoil piles need to be a minimum of 2 feet from the edge of the excavation and or the ditch. Those guys know that. They know how far they're supposed to move that dirt away from the edge of that ditch. So, safe workers are productive workers. Encourage all workers to make safety a lifestyle, not just something that you do at work. Do you wear your hearing protection when you weed at home? Do you do it in shorts and tennis shoes or flip-flops or Crocs? I don't. I've tried to make safety a lifestyle for myself. And if not for yourself, then how about for your wife, your significant other, your mom, your dad, your grandma, your grandpa, your kids, your pets? I've seen an alcoholic beverage commercial on television. It shows a dog looking out the window, and this guy's been driving and drinking. And it says, hey, the dog wonders. What it amounts to is the dog wonders where the guy went because he didn't come back home. There's a lot of things to be safe for out there. Find out what your reason is, and then turn safety into a lifestyle so that you can continue to be around. I think MG will probably throw his slide up there now with 811. He's probably has some information to do. I appreciate everybody today being here. MG has my contact information. If you have some kind of question you want to send to me, feel free to do that, and I'll try to answer it. I would also ask each and every one of you, if you have a critique, if you have a suggestion, or something that will make me a better presenter at any time in the future, not just for 811. I do training on a daily basis. If you would please send that to me so that I can become better at what I do. That's my ultimate goal, is to be the best that I can, and I do appreciate everyone. MG, thanks again for allowing me to participate in this expo, and looking forward to when we can go back live again in the near future.
Oh, I agree completely. Buddy, go ahead and show that last slide about the last one of your presentation. If you'll just back up just one. Okay. This is something that Buddy and I have had conversations about, and something that I also want just to echo. Throughout this expo that we're going to be doing, throughout any training that Buddy's a part of or I'm a part of, he and I both want to stress that lifestyle of being safe. It's not just what happens when you're on the clock. It's also when you're off the clock. Like Buddy's example of taking those extra precautions even at home when you're mowing. Throw on the clothing that's necessary, and hearing protection, things like that. Because when your mindset is everything needs to be safe, then you're hyper aware of things that aren't. And so whether you're doing it just so you're safe, that's a start. If you're doing it for your future, for your family, for your friends, then it just becomes easier and easier as you go. So, Buddy, I just wanted to echo that. You've done a great job illustrating safe excavation and trenching today. There has been a couple questions. One is regarding white linings. White lining in Oklahoma, unfortunately, is not in the law. It is a best practice. A best practice means that it's an industry standard that if you do this, it's the best practice. It's the best way to signal to the locators where your work site is, especially within a property or within an address. So while it's not in the law yet, it is going to help that communication that goes through when tickets are processed. If you can say, hey, yeah, I'm working at this property and there's a white or stake with a white flag in the backyard, locate a radius of it. That is so much quicker and easier than locate a full backyard, because I don't have time to go put out white paint, right? The other information coming in for us, buddy, is just compliments that you gave great information, and we appreciate that. So since we are coming up on the hour, let me go ahead and give you a chance to win a $100 gift card to Amazon. So let me put this in. I am sending off a question into the chat for everybody. The first person who responds with the correct answer will receive a $100 gift card to Amazon. So if you know the answer and you can't take a $100 gift, please don't answer. Don't confuse me. So I am sending the question now. So what does CP stand for in the following? An OSHA CP is defined as one who is capable of identifying existing and predictable hazards in surroundings or working conditions which are unsanitary, hazardous, or dangerous to employees, and who has authorization to take prompt corrective measures to eliminate them. Oh yeah, I love all these answers, all of them. And the first answer is Kevin Spicer. The answer is competent person. So I appreciate everybody who paid attention. Competent persons are huge. Buddy did a great job of explaining that. Make sure that on your work site, before you do your job safety or job hazard analysis, that everybody going into the work site knows who their competent person is, who's going to be taking the lead and making sure that everybody is safe throughout that project. So Kevin, I have your information. I'm going to put you on the list. Early next week will be when the emails come out from Amazon with your gift card. So I appreciate everybody who responded. We had almost 100% participation in sending in competent person. So I appreciate everybody who did that. So with that, buddy, do you have any thing you want to add before we close out today?
Hey, let's just all work safe. And next year when we do the 811 Expo and we do it at the Billy Bob's Meeting Barn or wherever we do it, you guys come out and let's all meet face to face.
Absolutely. I cannot wait for in-person trainings as well. In the meantime, I think you did a great job, buddy. I appreciate all the information that you shared today regarding safe trenching and excavation. To everybody who's attending, thank you so much. We look forward to seeing you at 3 o'clock for the next presentation. It's one of the few that isn't about digging. It's going to be about how to manage people who may not be like you. It's a great development session. So if you haven't won a gift card or you want to have a great session that involves a little bit more on the professional development, that's the one to attend. So thank you, everybody. Thank you for doing your part to keep Oklahoma safe. You all have a great day. Thank you.